Acids, bases and salts. Introduction. Students, you already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. If there is slight change in the color of red litmus, then it is distilled water. We eat fruits like mangoes, grapes, and oranges which have a sour taste. We are familiar with many acidic substances such as tamarind and lemon juice. These substances contain different acids in it. Some acids are sour in taste. Objectives. In this module, you will learn about the following. Identify acids and bases by using indicators. Illustrate reactions of acids with metals, metallic oxides and bases. Express reactions of bases with metals, non-metallic oxides and acids. Explain the use of pH scale in comparing strengths of acids and bases. Describe methods of preparation of some chemical compounds. Acids. The word acid comes from the Latin word acidus, which means sour. According to Arrhenius' theory, an acid is a substance which ionizes and gives hydrogen ions when dissolved in water. Example, hydrochloric acid in water releases H+ ions. HCl plus H2O gives H+ plus Cl-. A hydrogen ion cannot exist on its own, so it combines with a water molecule to form a hydronium ion. Example, hydrochloric acid when dissolved in water liberates a hydrogen ion and a chloride ion. The hydrogen ion combines with water to form a hydronium ion. Classification of acids. Based on the source, the acids were classified into two types. They are organic acids and inorganic acids. Organic acids. Acids obtained from food like curd, lemons, grapes, raw mango, citrus, fruits and gooseberry are called organic acids. Inorganic acids. Acids which are synthesized in the laboratory are called as inorganic acids or mineral acids. Following table is the list of some acids which are used in the laboratory. Name of the acid: sulfuric acid. Chemical formula: H2SO4. Nitric acid: HNO3. Hydrochloric acid: HCl. Acetic acid: CH3COOH. Classification of acids based on concentration. The word concentration indicates the quantity of acid in relative to the quantity of water in the aqueous solution of that acid. Highly concentrated acid contains high percentage of acid in comparison with water in that solution. Low concentrated acid contains low percentage of acid in comparison with water in that solution. Dilution of acid. Mixing an acid with water reduces the concentration of hydronium ions of the acid per unit volume. This is called dilution of acid. The action of acids with water is exothermic as heat is generated on dilution. Classification of acids based on strength. Based on ionization, the acids were classified into strong acids and weak acids. Strong acids. Acids which ionizes completely into its ions are called strong acids. Example, HCl, H2SO4, HNO3, etc. Weak acids. Acids which ionizes partially into its ions are called weak acids. Example, CH3COOH, H2CO3, etc. Classification of acids based on basicity of acids. Based on basicity, acids were classified into different types. They are monobasic acids, dibasic acids, tribasic acids. Monobasic acids. Acids which on ionization produces an hydrogen ion in water are termed as monobasic acids. Example, hydrochloric acid. Dibasic acids. Dibasic acids. Acids which on ionization produces two hydrogen ions are called as dibasic acid. Example, sulfuric acid, carbonic acid, etc. Tribasic acids. Acids which on ionization produces three hydrogen ions are called as tribasic acids. Example, phosphoric acid and phosphorus acid, etc. Properties of acids. Acids have corrosive action on skin. Acids are good conductors of electricity. Acid neutralizes bases to form salt and water. Chemical properties of acids. Reaction of acids with active metals. Acids reacts with metals to form metal salts. In this reaction, hydrogen gas is liberated. Example, in the reaction of hydrochloric acid reacts with zinc, produces hydrogen gas and zinc chloride. 2HCl plus Zn gives ZnCl2 plus H2. Reaction of acids with metal carbonates. Acids reacts with metal carbonates to form corresponding salts, carbon dioxide and water. Example, hydrochloric acid on reaction with sodium carbonate forms sodium chloride, carbon dioxide and water. 2HCl plus Na2CO3 gives rise to 2NaCl plus CO2 plus H2O. Reaction of acids with metal hydrogen carbonates. Acids reacts with metal hydrogen carbonates and form corresponding salts, carbon dioxide and water. Example, hydrochloric acid on reaction with sodium bicarbonate forms sodium chloride, carbon dioxide and water. HCl plus NaHCO3 gives rise to NaCl plus CO2 plus H2O. Reaction of acids with metal oxides. Acids reacts with metal oxide to form salt and water. Example, sulfuric acid on reaction with cupric oxide forms copper sulfate and water. Indicators. An acid-base indicator is a substance which exhibits different color in acids and bases. Red cabbage is a visual indicator used to detect acids. Onions are called olfactory indicators. They change their odor with change in the nature of solution. Litmus is a natural indicator and is extracted from lichens. Apart from natural indicators, there are a few synthetic indicators such as methyl orange and phenolphthalein. Following table gives colors of the indicators in the presence of acids and bases. Indicator: methyl orange in an acidic medium is red, in a basic medium is yellow. Phenolphthalein in acidic medium is colorless, in a basic medium is pink. Blue litmus paper in acidic medium changes into red color, in a basic medium does not change. Red litmus paper in acidic medium does not change, in basic medium changes to blue color. Universal indicator is a mixture of different number of indicators which shows different colors in different solutions. Uses of acids. Sulfuric acid is used in the manufacture of fertilizers, paints, dyes, chemicals, plastics and synthetic fibers. Sulfuric acid is also used in car batteries. Nitric acid is used in the manufacture of fertilizers, explosives like TNT, dyes and drugs. Hydrochloric acid is used before galvanizing to remove oxide film from steel and also as a descaling agent for boilers. It is also used in the textile, leather and food industry. Hydrochloric acid used in the manufacture of glucose from cornstarch. Ethanoic acid is used for coagulating latex to prepare rubber from it. It is also used in the preparation of perfumes. Boric acid is useful as an antiseptic and insecticide. Boric acid is useful as a flame retardant. Carbonic acid is useful in the form of carbonated drinks. Bases. According to Arrhenius' theory, any substance that can produce hydroxide ions when dissolved in water is called as a base. Substance plus water gives metal ion plus OH minus. Example, NaOH gives Na plus OH minus. A base is said to be an alkali if it is soluble in water. In general, hydroxides of alkali metals and alkaline earth metals are considered as alkalis. Example, KOH gives K plus OH minus. Bases. It is not necessary that a base should contain hydroxide ion. There are some bases even they does not contain hydroxide ion can be considered as bases. Example, ammonia. Ammonia when dissolved in water forms ammonium hydroxide which is a weak base. NH3 plus H2O gives NH4OH. Oxides of alkali metals and alkaline earth metals are also considered as basic in nature. Example, calcium oxide, magnesium oxide, sodium oxide and potassium oxide, etc. Classification of bases. Classification based on the strength. Based on the extent of ionization, bases are classified into strong bases and weak bases. Strong bases. The bases which undergoes complete ionization in aqueous solution are called as strong bases. Example, sodium hydroxide, potassium hydroxide, etc. Weak bases. The bases which undergoes partial ionization in aqueous solution are called weak bases. Example, ammonium hydroxide, ammonia, etc. Physical properties of bases. Bases are bitter to taste, soapy to touch. Bases are good conductors of electricity in aqueous solution. In aqueous solution, they release ions, which conduct electricity. Indicators in presence of bases. Bases turns red litmus to blue. Phenolphthalein turns pink in presence of bases. Methyl orange turns to yellow in presence of bases. Chemical properties. Reaction with active metals. Bases react with metals to liberate hydrogen gas. Example, sodium hydroxide react with zinc and liberate hydrogen and sodium zincate. Reaction with non-metal oxides. Bases react with non-metallic oxides to form salt and water. This is similar to a neutralization reaction between an acid and a base. Example, calcium hydroxide reacts with carbon dioxide to form calcium carbonate and water. From this reaction, it can be concluded that non-metallic oxides are acidic in nature. Uses of bases. Mild bases neutralize the acidity in the stomach. Sodium hydroxide is used in manufacture of soaps, paper, and synthetic fibers like rayon. Calcium hydroxide is used in the manufacture of bleaching powder. Bleaching powder is used as a disinfectant. Magnesium hydroxide is used as an antacid to neutralize the acid in the stomach. Ammonium hydroxide is used in the preparation of fertilizers like ammonium phosphate and ammonium sulfate. How do acids and bases react with each other? Bases react with acids to form salts and water. It is known as a neutralization reaction. Example: potassium hydroxide reacts with hydrochloric acid to form potassium chloride and water. An acid or base is considered as strong or weak depending on the concentration of hydrogen and hydroxide ions within it. This concentration or the power of hydrogen differs from substance to substance and can be measured using a scale called the pH scale. A solution that has a pH value of less than 7 is acidic, and a solution with a pH value of more than 7 is basic. A neutral solution is indicated by a pH value of 7 on the scale. Strong acids will possess pH values between 0 to 2 and weak acids possess pH values more than 3. Strong bases will possess pH values between 12 to 14 and weak bases possess pH values less than 12. pH of some of the acids and bases. Acids or base. Hydrochloric acid, pH value is 0.1 to 1.0. Sulfuric acid, the pH value is 1.0 to 1.2. Phosphoric acid, the pH value is 1.3 to 1.5. Acetic acid, vinegar, the pH value is 2.9 to 3.0. Carbonic acid, the pH value is 3.8 to 4.0. Water, the pH value is 6.9 to 7.0. Ammonia, the pH value is 10.8 to 11.2. Sodium hydroxide, the pH value is 13 to 14. Applications of neutralization concept in daily life. Antacids like milk of magnesia are mild bases that neutralize the acids in the stomach and aid digestion. If the pH lowers, the acidity in the mouth increases and leads to the tooth decay. Toothpastes are basic in nature and they counteract the acid in the mouth. Hydrangea produce pink flowers when the soil has a pH value of 6.8 or higher, and blue flowers when the pH value is 6.0 or less. If the soil is acidic, then the applied pesticides, herbicides, and fungicides will not be absorbed by the soil. In order to neutralize the soil, suitable bases are used. Generally, salts of calcium or magnesium, which are basic, are used to neutralize soil acidity. When a bee stings, formic acid is released. That is what makes the skin burn. Baking soda, which is a base, neutralizes the formic acid and provides relief from the pain. Salts and their properties. The compounds formed by the reaction between an acids and bases are known as salts. Acid plus base gives salt plus water. Salts are ionic compounds which contain positively charged cations and negatively charged anions. During salt formation, cation is coming from base and anion is coming from acid. Example: in sodium chloride formation, cation sodium is coming from sodium hydroxide and anion chlorine is coming from hydrochloric acid. Table below giving neutral, acidic and basic salts. Type of salt. Neutral, pH is equal to 7. Type of acid. Strong acids. Examples: hydrochloric acid, sulfuric acid. Type of base. Strong bases. Examples: sodium hydroxide, potassium hydroxide. Example: sodium chloride, potassium sulfate. Type of salt: acidic, pH is less than 7. Type of acid: strong acids. Examples: hydrochloric acid, nitric acid. Type of base: strong bases. Examples: ammonium hydroxide, magnesium hydroxide. Example: ammonium chloride, magnesium nitrite. Type of salt: basic, pH greater than 7. Type of acid: weak acids. Examples: carbonic acid, acetic acid. Type of base: strong bases. Examples: sodium hydroxide, potassium hydroxide. Example: sodium carbonate, potassium acetate. Salts in our daily life: baking soda. Chemical name: sodium hydrogen carbonate. Molecular formula: NaHCO3. Sodium hydrogen carbonate is commonly called as baking soda. Sodium hydrogen carbonate is used in the baking industry. It is used in preparation of soda acid. It is also used in foam-type fire extinguishers. Washing soda. Molecular formula: Na2CO3 10H2O. Chemical formula: sodium carbonate decahydrate. Adding water to sodium carbonate and allowing this mixture to cool to form decahydrated sodium carbonate. This is commonly called as washing soda. Na2CO3 plus 10H2O gives Na2CO3 10H2O. In general, sodium carbonate is prepared by passing carbon dioxide gas through concentrated sodium hydroxide. 2NaOH plus CO2 gives Na2CO3 plus H2O. Uses of washing soda. Sodium carbonate is used in glass, soap and paper industries. It is used in the manufacture of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness. Water. Bleaching powder. CaOCl2. Bleaching powder, chemically known as calcium oxychloride. It is prepared by the reaction between chlorine and slaked lime at about 40 degrees centigrade. It acts as a strong oxidizing agent to bleach substances. Calcium hydroxide plus chlorine gives calcium hypochlorite and water. Calcium hydroxide plus sulfuric acid gives calcium sulfate and water. Uses of bleaching powder. It is used to bleach cotton, linen textiles and wood pulp. Colored matter plus bleaching powder gives colorless product. It is also used to disinfect drinking water. Hydrated salts. The molecules of salts which contain fixed number of water molecules in them are called hydrated salts. In general, they exist as dry in pure form. These salts on heating loses water molecules in them and forms anhydrous salts. Example: ferrous sulfate, heptahydrate, FeSO4 7H2O. On heating, loses water molecules in it. FeSO4 7H2O. On heating, gives FeSO4 plus 7H2O. Some of the hydrated salts along with the chemical formula. Name of the salt: sodium carbonate decahydrate. Chemical formula: Na2CO3 10H2O. Name of the salt: zinc sulfate heptahydrate or white vitriol. Chemical formula ZnSO4 7H2O. Name of the salt: magnesium sulfate, heptahydrate or Epsom salt. Chemical formula MgSO4 7H2O. Name of the salt: potash alum. Chemical formula K2SO4 Al2 SO4 thrice 24H2O. Name of the salt: copper 2 sulfate pentahydrate or blue vitriol. Chemical formula CuSO4 5H2O. Name of the salt: calcium sulfate dihydrate or gypsum. Chemical formula CaSO4 2H2O. Plaster of Paris CaSO4 half H2O. Plaster of Paris, which is chemically called calcium sulfate hemihydrate, since it is brought to use from Paris, called as plaster of Paris. It is prepared by heating of gypsum at 373 Kelvin. CaSO4 2H2O gives CaSO4 half H2O plus half H2O. Uses of plaster of Paris. It is used as a bandage, proofing material, sealing agent. It is used for making statues, toys and decorative articles. It is also used for smoothing wall surfaces. Conclusion. Students, in this chapter we have learned the following: identification of acids and bases with the help of indicators. Acids and bases conduct electricity. Acids react with metal carbonates and metal hydrogen carbonates to give salts, carbon dioxide and water. Generally, metal react with acids to produce hydrogen gas and salt. Strength of acids and bases is measured using a scale called pH scale, 0 to 14. Acids and bases react to form salt solutions which are neutral. They are exothermic reactions. Salts like sodium carbonate, bleaching powder, sodium bicarbonate have varied uses in our day-to-day life.